Thank you, David. Pleasure to be with your group today. People ask me, what is it that I do? Well, I'm a silver geologist, and people go, well, why silver? And why devote 40 years of your life to a commodity that has seen more downs than ups when you could have been involved in something like gold? Well, fundamentally, to me, silver is a more interesting element than gold. Gold basically just sits there, and that's its beauty. It just sits there. Nothing happens to it. It remains, almost every ounce of gold that's ever been mined is still on the planet. Silver, on the other hand, is a very active metal. It gets involved in all kinds of chemical reactions, mineralogical reactions, a lot of things that I find are very interesting, and that translates to the geology of where silver deposits are and how and why you look for them. And anybody who knows me knows that my mantra is look for grade, and then look for grade. And then once you've found grade, look for size. And grade is king as long as you're finding something that makes money under any market conditions. And even if that's silver at $3.50 an ounce, and it's big enough to survive at least 2 market cycles, then you have the makings of a major discovery. And I've been fortunate that my team and I have made a couple of major discoveries that fit that particular metric. One of the interesting things that's happened over the last 10 years or so is the recognition that silver is the green metal. And when I say that, I mean silver is involved in all of the green technology, which is becoming so important in the modern world. It is involved in solar panels. Almost 10%, actually a little more than 10% of the world's annual production of 850 million ounces of silver gets involved in photovoltaic cells. And about another 100 to 150 million goes into conventional and electric automobiles and is anticipated to grow further. Plus, there's a significant amount of silver that goes into passive biomedical uses. And that simply means that silver kills bacteria just because of the way silver works. And so you don't need antibiotics in a lot of cases. And you can cut down on the transmission of all kinds of infectious disease by coating surfaces with silver. So the short story here is that silver is the metal for the environmental future. People think of silver and they go, well, we don't use as much silver anymore. 50% of silver used to go into photography. Well, and that's gone. And actually what people don't recognize is that most of the silver that went into photography was essentially a treadmill. There was almost as much recycling as there was use of silver. So silver used to be primarily a monetary commodity. Better than 60% of silver's current consumption, and we consume about 1.05 billion ounces of silver a year worldwide. We produce about 850, so there's about a 200 million ounce shortfall, which is made up out of the scrap market and things like that. But 60% of that total is industrial, and that didn't used to be the case. I mean, we still make some silverware, and 200 million ounces of silver goes into jewelry every year, and about another 200 million ounces goes into bullion. But most of it is into these industrial applications, which are dominated by electronics, biomedical, and solar. So the demand for silver is very strong. Unlike things like gold, lithium, vanadium, silver tends to travel with a lot of other elements. Doesn't tend to travel by itself. So you find silver as a co-metal in lead zinc deposits, in copper deposits, in gold deposits. Very seldom does silver occur by itself. In fact, about 70 to 75% of the world's silver production is byproduct from mining of copper, lead, and zinc, which means that when the silver demand increases because of supply side squeeze, it's very difficult to ramp up the production of silver except through primary silver mines. Most primary silver mines are small, and it's very difficult to ramp up the production on them very significantly, which means from an investment standpoint, when silver experiences a supply side squeeze, it tends to move very, very quickly. Most of the time, silver follows along behind gold because people think of it as this monetary poor cousin to gold. But actually, silver has much more potential leverage to industrial demand and technological advance than gold does. When you look at the history of mining during the 20th century, the focus shifted from 19th century underground mining to large-scale open pit mining. So what we saw was a transition from underground mines to these giant open pit mines, which we see all over the world today. And these are the bane of a lot of people's existence. They're, especially from an environmental standpoint, they tend to make very large permanent waste dumps on the surface, huge tailings impoundments that are regulated in some environments, less regulated in others. But the beauty of silver is it tends to form in high-grade deposits that can be mined underground on a fairly large scale. So what we're seeing is a transition in the 21st century away from the big open pit mines to large-scale underground mines, highly technologically advanced, in some cases largely robotic, so there's very few people who are endangered in the process of the mining, and you wind up with a very minimal environmental footprint. And so the combination of a high dollar product, a low environmental footprint, makes these very attractive deposits as we move forward. The human race is not going to stop using things. Things are made of stuff. Stuff comes from somewhere. If it's not grown, it's mined, and all of this sounds like a bunch of cliches, but it basically boils down to that. And for silver, it comes with other metals, which are useful. And if we can mine it cleanly in a regulated environment, as opposed to environmental imperialism, where we outsource not only our mining but our environmental problems, then it is really the kind of way I think the world should be looking towards producing these metals as we move on into the 21st century and become increasingly aware of the fact that we are, A, not the only residents on this planet, but B, we have to find a way to mitigate some of the environmental impacts that the human race has had on the planet, or perhaps even simply mitigate environmental changes that we're seeing happening on the planet with or without our involvement. So where do you go from here in terms of exploration? What kind of deposits, what kind of companies do I get involved with? I tend to get involved with companies who are looking for finding high-grade underground opportunities with a significant silver component, not necessarily exclusively silver, but with a significant silver component, because that's the metal I like. That means you get copper, you get lead, you get zinc, you get some gold that comes along with it. When you look again at the history of mining and exploration in the 20th century, with the focus on large-scale, low-grade, open-pit mining, there was an enormous amount of exploration effort that went into finding these deposits. And what we now recognize is that surrounding a lot of these deposits, especially the also-rans, the ones that didn't make it, they weren't big enough, they weren't high enough grade to make it as an open pit mine, or they weren't consistent enough, a number of these properties have enormous high-grade lead, zinc, silver, copper, gold replacement bodies around them. And that's what I work with. So this is almost any time you have one of these intrusive systems placed into carbonate rocks, limestones and dolomites, you can make a big system. And in the example, the best example I can think of practically that I can see out my window is the Taylor deposit in southern Arizona, which is a giant high-grade silver, lead, zinc, copper, gold manto which surrounds a porphyry copper which never made it from an economic standpoint. And there are literally hundreds of these deposits like the Sunnyside porphyry, which don't make it as a porphyry, but are potentially surrounded by the kinds of high-grade deposits that I like to look for. So we have a tremendous amount of legacy data that we can use to come up with a new twist to find something. Because my exploration mantra is, if you go into an exploration program doing what other people have done before you, you're not going to find anything. Because if that worked, they would have found it. But you can take the work that they did, reprocess it, and come up with a new idea with a new target, and potentially make significant discoveries very quickly. Those are the kinds of things I like to do. Big, high-grade discoveries, preferably in places that are responsible and regulated jurisdictions. And with that, I thank you very much for your attention and hope you enjoy the webinar.